In this video, we're going to be determining whether a linear function is increasing, decreasing, or constant. So you can do that by analyzing the slope. So if the slope is a positive number, the line will be going uphill or increasing. If the slope is a negative number, the line is going to be going downhill or decreasing. And then if the slope is zero, which if we look at what that would look like in a y equals mx plus b form, right? If m is zero, it doesn't really matter the value of b. We lose the x variable. Zero times anything is just zero. So we just have y equals some number. Okay, so that's what a slope of zero would look like. We just have a y equals a number equation. And that's going to be a horizontal line. So that would have a slope of zero. That would be a constant line. Now we can also have an equation x equals a number. That would be a vertical line. And remember that type of line we say is undefined. It has undefined slope. And therefore, it's not increasing, it's not decreasing, and it's not constant. It's none of those things. Okay, so taking a look at some examples here. Our first example, we have the equation y equals 2x plus 4. That's already in the format y equals mx plus b. So we're going to analyze the slope and just look at sign. It's a positive number, so therefore this is going to be an uphill line and therefore increasing in behavior. All right, the next example, if we take a look, this is still in y equals mx plus b form, but the order, they've reversed the b and the m. So I'm going to rewrite that. Make sure you're keeping the sign in front of the number. The sign in front of the number stays with the number. So I would rewrite this as negative 3x plus 5. So again, I'm analyzing the slope. It's a negative number, so this is going to be decreasing, or the line is going to be going downhill. All right, the next example, it's already in y equals mx plus b form. We do have a fraction. That does not matter. It's still a positive number, so this one's going to be increasing, going uphill from left to right. Number 4, if we take a look at the slope is a negative number, so that means it's going to be decreasing, going downhill from left to right. This next example, y equals 3. Notice it's just y equals a number. So this is going to be that constant scenario, since the slope would have to be 0 in order to get rid of that x variable. Okay, this next example is in point slope form, which is another form of a linear function. However, we can transform this into slope intercept form very easily if I wanted to by distributing that negative 5, so negative 5x and then plus 15. We could add 1 to both sides, so it's in slope intercept form. Negative 5x plus 16. We're just analyzing the slope, which notice the slope was this number in front of the parentheses. So point slope form is y minus y1. So a particular y value, a point on the graph, its y value, is equal to m times x minus x1. So this indicates that a point on the graph is 3, 1, and it has a slope of negative 5. So you don't really have to transform that, but if you would like it to be in y equals mx plus b form, of course, you can do that at any time. We're analyzing that slope. The slope is negative, and therefore this would be a decreasing line. So on this last example, notice that it is still in point slope form. So I'm not going to transform this to slope intercept form. I'm just going to use the idea that the slope is always in front of the parentheses. So notice this slope is positive, and therefore it would be increasing from left to right.